Hi everyone, I hope you all are doing well. Welcome to day 7 of Array and String Mastery series for placements at Aarush Coaching Classes. So let's quickly see what we have covered in the last class. So yesterday we covered size sliding windows where we understood things by solving two major problems which are most frequently asked in interviews, basically for the farm companies and other big major companies. Okay, so the first problem was about longest unique subarray where we used a hash map to track the character positions. Okay, and then the next question was about minimum subarray sum, where we saw the actual implementation of the variable size sliding window, where we expanded the right pointer or right hand side till we reached the target sum. Then to find the minimal length of the array of the subarray, we started checking the left hand side. That's what the strategy that we used yesterday. So it overall gave you the clarity for the dynamic window adjustment based on conditions. So same time we covered our journey from brute force solution to the optimal transformation, which was nothing but from polynomial solution to the linear solution. Now today at Aarush coaching classes, we are gonna discuss hashing mastery. We are gonna achieve hashing mastery. How? Again, it is better learning while doing instead of just thinking and discussing about the theoretical approach and that's all. It takes too long. But the best way to learn DSA is learning by doing. Okay, so that's why we will be picking again two problems in today's session. We will discuss it, we will solve it, and while solving, we will cover most of the things so that the whole idea, whole concepts would be clear to you. Okay, so first problem that we are going to discuss today is subarrays sum equals k, where we are gonna use the approach of having the prefix sums plus hash map to get the frequencies. So don't worry, I am gonna explain it later when I am discussing that particular problem. So for now, let's be with this current statement. Next problem that we are gonna discuss is array permutations, where we are gonna deal with the frequency distribution and comparisons. Okay, so in while solving these two problems, these would not just give us clarity about how the technique is being applied. Instead, this will also show how mathematics actually help you in building the pattern and recognizing it as well. Okay, so that's why I've written mathematical transformation for optimization. See, people, you don't need to worry about maths too much because बहुत high level की maths नहीं आती, not from the class 12th level. Basic school mathematics is basically required here, है ना? So that mathematics gives you idea about the pattern plus what things are needed to be pre-computed so that you can make your solution better, or you can say optimized. Okay, so that's all about the mathematics that is going to be used here, not like some space, or you can say some rocket science kind of maths. ऐसा नहीं use होता कोई, ठीक है? Basic equation, linear equation based basic addition, subtraction, division, that's what we use. Okay, and we'll see how the space and time complexity trade-off design actually works. Okay, and for the real world applications, it is always better to connect with what we are learning and where it is gonna be used in real world, I know. So you must be dealing with multiple applications, using multiple applications where they deal with data streams, live data streams, other kind of data streams, you know. So in processing of those data streams, because data stream works in a time frame manner, you know. So obviously that time frame is all about windows mostly. So that's why it is also used. Network packet analysis, again for networks also time frames में होते हैं. Then real time monitoring system. So that's the sliding windows are used. Now for the hashing patterns, it makes the lookup very easy. And if you're looking for something in a huge amount of data, or something somewhere something is kept, I mean, too many things are kept, and you want to find something, right? So that's where hashing pattern is used mostly. So like database have too much of the data. So in database indexing, hashing is used. Okay, then cache implementations, then frequency analysis and big data. So you can see the pattern here. Wherever a huge amount of data is involved, and you want to, I mean, get things quicker, then their hashing is used. Okay, so let's move to understand it first. What is hashing? So hashing is nothing but a technique to map data to fix the size values for in order one axis. So it's written in a little technical way, but in short, let me tell you by this example that we have on this screen. Okay, so let's say you have some array and or a list of data which have too much of the data and you want to find something. So obviously, if you want to find it, you will check one item after another, correct? One by one, you will be checking every item because you know what, at least some information you have what you're looking for. Like if you are looking for the pin code, है ना? Pin code, then at least you know the city name, correct? City name, pin code, or you can say the dial code, whatever it is for the landlines we used to use, right? So city name. So if you have city name and you are looking for dial code, okay, for that city, and there are too many such cities, you know, 100, 200 cities are there. You have all these entries. So what you are gonna do in normal, while normally looking up for this data, you will check for here city name. Let's say it is Delhi, or you can say this is चलो दिल्ली कर लेते हैं ठीक है let's say it is Delhi, okay, not exactly the city but yeah I am taking, or in short, just to be factually correct, let's take Bangalore, BLR. Okay, so BLR, you came here, you checked BLR's entry, no, 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 check all the way through here you got the entry of BLR, then you got the dial code, let's say 0542, you know, that was the code for BLR. So that's how you will get. So if BLR is entered at the very last of this data, so you are gonna go to whole data. So if there are n items, so this lookup or searching would take order of n, correct? But with hashing how it works internally, you don't need to worry about it right now because mostly you're using it, and in the documentation you can read about it later in Java, how hashing work, what is the data structure used behind this, and how the lookup works. But what you need to majorly consider right now is that this lookup takes order one time, constant time लेता है, constant time. So let's say you have this detail of Bangalore and you are looking for the dial code for Bangalore. So if hashing is used to keep this data or to store this data, then quickly you will reach the entry having Bangalore and the code would be 0542 is what you are gonna get there. Okay, it happens very quickly. So that's why hashing becomes you can say most optimized way in terms of looking up something. So transforms search problems into lookup problems. ऐसा कर देता है, ठीक है? Perfect for frequency counting and extents check as well. Means if something exists like Bangalore exists, then only Bangalore have an entry, है ना? And Bangalore कितनी बार किसी और चीज में आता है, that also you can store in different kind of scenario, है ना? So that's why hashing is used and that's how it helps. Real world analogy, just you can think of that think of a library catalog, okay, so instead of checking every shelf, because if you go are finding for something and you are going to check each and every shelf, let's say there are n shelves, then you are going to check those n shelves and then you are going to look for the book. But if it is hashed properly, some index is there, remember in the book there's a book, correct? एक बुक होती है, उसमें क्या होता है, on the initial pages what is there, index page. So if you know already the chapter, then you can go to page number. Yes or no? Directly. If you know the chapter, you know the page, you will get the page number. From page number, you can directly go to that page number in the book. You don't need to go one by one. Correct? One by one, one after two, then three, then four. You don't need to do this. Correct? You just directly go there by skipping the pages. So that's how it really happens and it really helps. Okay, so when to use hashing? When problems involving frequency counting, check for duplicates or resistance, when brute force involves needed, nested loops. For in terms, I mean these two are for the optimizations. Okay, so you need to identify the pattern and implement the pattern if it is getting applied, and you will get the optimal solution there. Okay, so I hope hashing is clear at least till here. You don't need to worry about much. Okay, let's try to understand more about it, how about the implementation and the scenarios by going through a problem statement. So the major problem statement here is that we are going to solve today and which is mostly asked in the interviews is subarray sum equals k. So in short, it is saying Given an array of integers named as nums and an integer k, you need to return the total number of contiguous subarrays where sum equals k. So let's say if you have this much long array, है ना, there are different subarrays. Subarrays कहाँ से कहाँ तक होगी? Let's say if these are all the items, then there can be too many subarrays, है ना? How many exactly I'm not telling you right now because we will discuss it later. But yeah, how many possible subarrays? That particularly, I mean, I can ask a question from you as well that you can put in the comment for an array of size n, how many subarrays are possible? You can write in the chat. Okay, subarrays are possible. Okay, little mathematics is also involved here, but that's what you need to learn about. Okay. Now, so these are the surveys possible. यहाँ से यहाँ भी हो सकता है. From here till here also survey is possible. Even from here till here, there are too many contiguous surveys are possible. So what this question is asking about it, you are given with an array and a target k. You need to return the total number of such subarrays, contiguous subarrays, whose sum of items equal to k. Like here, if you see, the array that I have here right now is 1, 1, and 1. Okay, and let's say k is given 2. So how many such subarrays are there whose sum of items is equal to k or 2? So if I do this 0, 1 and 2 index, so 1 plus 1 equals to 2. Yes, one subarray है ना? Count कितना हो गया? How much is the count? Count is 1 right now. If I do this, this is also subarray, contiguous subarray. 1, 1. 1 plus 1 equals to 2. So count of कितना हो गया? 2 हो गया. Is there any other contiguous subarray whose item sum is gonna be equal to 2? नहीं है. So that's why answer is 2 only. And the index is 0, 1 and 1, 2. That's what is written here. Similarly for this array with negative numbers also. Here is the catch, people. Earlier we have mostly solved problems having positive numbers, but here there can be multiple negative items as well. So that's why some can be 0 as well. So you can't, this itself tells you that you can't go with the fixed sliding order directly or any sliding order directly. You need to think a little deeper. Okay, when you're dealing with negative numbers, so you need to be very careful if you are thinking in the direction of sliding window only. Okay, so let's try to solve this, or instead let's try to get this है ना, इसमें ज़्यादा negative numbers and positives भी है, and k is also 0. So your target is 0. So 1, 2, 3, minus 3, minus 2, minus 1. These are all the items in the array, and the target sum given to us is k is equals to 0. So what we can do here is, let's see. Here indexes are 0, 1, 2, 3, 4 and 5. सम 0 निकालना है. कौन कौन सा array हो सकता है? 1 plus 2 नहीं हो सकता. 1 plus 2 plus 3 नहीं हो सकता. 1, 1, 2, 1, 2, 3, no. It can't be 0 because all of the positive items. Then 1, 2, 3 and minus 3. It will give again 3 there because these 3 and minus 3 would become 0. Okay, then 1, 2, 3, minus 3, minus 2. Correct? This will give you what? 1. 1, 1, 2, minus 3. So 3 is also 3 only. Minus 3, minus 2, minus 1. The sum would be 0 here. You know? So if I start from 1, this is the subarrays that I can get, and then the sum of those items would be these much. Okay, 3, 2, 5 plus 1, 6, 1 plus 2, 3. It's got the 1 here. Okay, so this is the subarray that I'm getting. Next, if I start with this subarray from 2, so 2, 2, 3, 2, 3 minus 3, 2, 3 minus 3 minus 2, 2, 3 minus 3 minus 2 minus 1. What will the sum? इसका 2 ही होगा. 3, 2, 5. Here 2 only. Here 0. And here it would be minus 1. So this one is also one such subarray. Now if I start with this 3, 3, 3, comma minus 3, 3 minus 3 minus 2, 3 minus 3 minus 2 and minus 1. What would the sum? 3, sum 0, sum minus 2, sum minus 3. So this one is also there. If I start with, now you can see all the negatives only. Though if I show you, but you are not gonna get the answer somewhere. Like if I start from -3, you will get these much subarrays. -3, -3, -2, -3, -2, -1, -3, -5, -6. Okay, no zeros. And if I start with -2, you'll get the items -2, -2, -1. Some would be -2, some would be -3. And if I start from -1 only, it will be -1. So some would be -1 only. So these are all the subarrays that you can get. Okay. And from all these subarrays, you just need to check or you can count how many subarrays items sum are 0. Okay. So you can see there are total 3 such subarrays whose item sum is equal to 0. This one, and this one. And that's why the output is 3 only. So I hope I have made my point clear about what this final statement is actually about. And at the same time, I think by generating all the subarrays, I have cleared the most basic approach also about how to solve it. Yes. So as I have showed you all the subarrays and their item sum. So first basic approach would be around generating all the, I mean, for all subarrays, calculate items sum, and if sum is equal to 0, then count it in. काउंट इट इन काउंट प्लस प्लस हो जाएगा ओके सो अभी क्या करना पड़ेगा लाइक फॉर दिस सो फॉर I इक्वल्स टू 0 I sorry, less than n I plus plus and inner for loop j is equals to 0 j equals to actually I होगा ना हमेशा I से स्टार्ट होता है j less than n j plus plus what next with j would be because if I start from 0 so j would be also be starting from 0 है ना तो सम क्या होगा 1 आएगा फर्स्ट टाइम पे so let's have the sum also so initialize sum equals to 0 here so sum plus equals to nums j okay so 1 आएगा if sum equals to k अगर ये k के इक्वल आता है then what do you need to do increment the count plus equals to 1 okay ये कर सकते हो otherwise you don't need to change the value of count okay that's what we're doing है ना 1 आया तो 1 2 के इक्वल नहीं था यहाँ पे क्योंकि k 2 है गिवन है सो नहीं किया यहाँ पे सम 2 कर देते हैं ओके नाउ देन jth inner loop moved forward है ना I यहाँ पे था j यहाँ पे था then j came here 0 1 2 okay then one more one so 1 plus 1 equals to 2 हुआ यहाँ पे sum की value once it have become 2 then it was a k so count plus 1 initially put count equals to 0 okay then if I go to the next item and a j यहाँ पे आ गया one more one so the sum would become 3 this time is 3 equals to 2 no it is not so that's why the for loop over both okay and once everything is calculated you will just return the value of count okay that's how it is gonna work so here you can see very clearly in this code also array is given target is given okay I am putting count equals to 0 initially then starting with 0th index till nums.length start places try every possible starting point then expand subarray from current start position so end is starting from the start pointer and is less than nums.length then end places current sum I am initializing at 0 initially so current sum plus equals to nums end okay the more items is getting added in the subarray those items would get added in the current sum. Now check if current sum equals to target. If it is equals to k, then count pluses, otherwise don't do anything. And that's how this whole for loop things are gonna function. And once we achieve our target, we'll keep incrementing our count. And once the whole subarray generation is over, we'll just return our count value. Okay, and that's how it is. Now let's see टाइम क्या होगा इसका? टाइम कॉन्स्टेंट एज we can see very clearly big of n square, all the subarrays are being generated. Space constraint we are using only the variables, that's why it would be constant for you, this particular solution. So why this is inefficient? Repeated calculations, sum of one comma one calculated multiple times. Yes, as you can see here, यहाँ पे from this page also, वन वन एक बार कैलकुलेट किया था 0 and 1 पे, एंड ये 1 and 2 का था इंडेक्स पे, करेक्ट? मल्टीपल टाइम्स इट वाज गेटिंग कैलकुलेटेड, दैट्स व्हाई इट डिडंट वर्क. नो मेमोरी, doesn't remember previous computations, so recomputation is happening, है ना? Recomputation is happening. So that's the, you can say, very very big sign of where you can optimize things, where you can start optimize things, you know, you can identify through this. Because wherever repetition is there, then you should try to avoid it, because it's costing you the time, it's costing you more complexity. Okay, so recomputation is happening here. Inefficient exploration, many overlapping surveys checked. We have seen it already, है ना? So time complexity have become order of n square. So we need to fix this. We need to, you can say, reduce it to linear time complexity. Space complexity is big of one because only constant extra space we have used to the variables, है ना? So let's have a optimal insight versus, I mean, proper insight from the brute force versus optimal approach. Okay. सो क्या गलत था ब्रूट फोर्स के साथ? वी वर रिकैलकुलेटिंग सम, है ना? सब अरे वन वन आ गया था कैलकुलेटेड सेपरेटली फ्रॉम डिफरेंट स्टार्टिंग पॉइंट्स, दो वी अचीव इट अर्लियर. So again, repeating things. Okay, no mathematical insight. So missing the relationship between prefix sum and subarray sums. This I will explain it completely to you later. Why? Because we have not talked about the prefix sums yet, but what prefix sum is, I will show you later. Don't worry about it. But what you need to focus upon here is mathematical insight. We could have achieved some pre-computation kind of thing using the mathematical formula, not some major formula, instead just addition subtraction only. So this is gonna play the key role here in terms of optimization. Inefficient pattern, checking every survey instead of using cumulative information. Again, not very, you can say, optimal. So optimal insight क्या होगा? Now let's think about this. Optimal insight में क्या होने वाला है? What is gonna happen there is, we are gonna use the prefix sums and hash map to track frequencies. किसकी frequency? Such sub-arrays whose sum of items are gonna be equal to k, है ना? So sub-array क्या होती है? Every sub-array have some क्या? Have starting, one start and one end point. Yes or no? होती है. So let's say for this array 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 12 items are there total, okay? If I were to mark any subarray, let's say my subarray is starting from index 4 and going till index 9, है ना? यहाँ तक जा रहा है, post 9 तक. So ये start होगा, ये end होगा, और I can call it ith index and jth index also, है ना? So what I can do is, if I write sum of I till jth index, okay, sum of items from I till jth index, if they are equal to k, है ना, then we need to count it in. Yes or no? ये होता है. That's what we are trying to achieve for any subarray. This sum I to j is what? Sum of items of subarray starting at ith index and at jth index. Yes or no? That's what is happening. I am calculating the sum of this subarray. If the sum of this subarray is equal to k, then I will be counting it in. So that's what I am looking for. So now, what is gonna be the prefix? Let me define what is a prefix. Okay, if not in the literal way, but when I say prefix, okay, this is a sum, okay. But if I write prefix of j, hold this idea, okay? Sum ij equals to k sub array का sum है, okay? Hold it, stick with it. Now let's grasp one more thing. If I write prefix of j, it means sum of items from 0th index till jth index. Getting the idea? What is prefix of j? Sum of all the items from 0th index till jth index. Like if I say 9 j is at 9 है ना, so ये कितना हो जाएगा sum, और इंस्टेड इसको हम क्या लिख देंगे, nums 0 plus nums 1 plus nums 2 plus so on till where, plus nums j. So we have tossed a term named prefix of j, which is nothing but equal to sum of all the items from 0th index till jth index. Okay, तो ये हो रहा होता है. Now, if prefix of j is like this, then for this subarray to get counted, in as a successful subarray whose sum is equal to k, can I mathematically represent like यहाँ से यहाँ तक, let's see again, from here till here, okay, 0th index till 9th index, what I have represented? Prefix j, है ना, मैंने ये represent किया हुआ है. और let's say then what is this particular, what this particular thing is then? This is my target subarray or subarray, interested subarray ना, subarray that I am interested है ना, ये subarray. तो can I say that this prefix j, ये जो है, is a sum of items from index 0 till I minus 1 and from I till j, yes or no? Prefix j is 0 to j, ठीक है? What is this thing then? This thing is, this particular part is, I can write prefix I minus 1, yes or no? Because it contains the sum of items from 0th index till I minus 1, yes or no? So what is prefix j contributing to? This gives a value of sum, this also gives a value of sum from 0 to j, this gives a value of sum from 0 to I minus 1 index, correct? So ये कितना हुआ फिर? सब एरे I to j है ना, ये I to j बोल लेता हूँ, ये कितना होता है फिर? What is the value of this? If I want to consider it in my counting, तो इसको टारगेट के इक्वल होगा, then I will count, which is k. So let's assume that it is equal to k. तो मैं क्या लिख सकता हूँ? Then what can I write? Then the formula will become like, let's say इसका sum k है, then k is equals to prefix of j minus, from this whole sum I will subtract this much amount of sum to get this much, which I have assumed that it is k. So I am trying to build a mathematical formula here, prefix of j minus prefix of I minus 1. That's what I am gonna get, because k is nothing but equal to, prefix of I to j. Okay, prefix of I to j, or instead of calling it prefix of I to j, I should call it sum of I to j, है ना? Because prefix we have considered something else. Sum of I till j, sum of items from I index to j index is equals to k, which is further equal to prefix of j minus prefix of I minus 1. Okay, that's what I wanted to give you the idea by giving a proper visualization. Otherwise, it wouldn't have made much sense earlier. Okay, so now let's see. That's what we are talking about here as well. Use prefix sums and hash map to track frequencies, So if we have assumed that this subarray sum is equal to k, that's what we're interested in. So we want to count all such subarrays whose sum is equal to k. So we really are interested in this particular thing, that if we have this and we have this, then the number of such occurrences would be counted, and that would give us total number of subarrays whose sum is equal to k. That's all what we are talking about here. That's all. है ना? So if sum is equals to I to j number, I mean sum of items from I to j equals to k, then that's exactly what is written here as well, what I have showed you. Prefix of j minus prefix of I minus 1 would be equal to k. So prefix of I minus 1 equals to prefix of j minus k. Prefix of j minus k. Because we can, when we have this kind of formula, there are three items, ना कौन से items है? There are three components actually. What are those components? कौन से components है? One is the k component, one is the prefix of j component, one is the prefix of I minus 1 component. Correct? है ना? K we know already. J we will keep calculating. Prefix of I minus 1, we don't know yet, but I minus 1, if we keep calculating, we can encounter somewhere. है ना? So that's why we are gonna create this formula, prefix of I minus 1 is equals to prefix of j, okay, minus k. So this is now we are gonna keep looking for. Don't worry. You might not get this completely till here, but once you try solving also, it will make clear sense. है ना? अभी जैसे formulas लिख रहे हैं. But at least if you are getting 90% or 80% of how this formula is written, that is also okay. Don't worry. है ना? तो अभी हमको ये देखना है. And wherever we are getting this, we just keep counting the frequency of that. है ना? कितने बार आ रखा है. So mathematical insight, we need to count how many previous prefix sums equal prefix sum, current prefix sum minus k. ये कहाँ से आएगा? As I written here, keep calculating, है ना? Because initially j की वैल्यू कैसी होगी? J is a variable, so we'll start from 0 till the whole array, है ना? तो j will get increased. So wherever j is, current prefix sum would be there, till there only. Okay. Now this transforms the problem into a variation of two sum. Remember two sum हमने क्या किया था? There was a formula that we used in two sum. क्या use किया था? Target was given, है ना? Target was given, and target was equivalent to a plus b. So if I was fixing a, then I was getting b is equals to target minus a. ये मिल रहा था हमें? Yes or no? B is equals to, we're getting b, and then here we used what? Hashing for this, for lookup. Same logic we're gonna use here also. Same we are gonna use here as well. Okay, same idea. So understand the pattern. We need to count subarray with sum k. Mathematical transformation क्या बन रहा है उसका? Sum from I to jth index, the sum of items would be equivalent to k, which is further equivalent to prefix of j minus prefix of I minus 1. Okay, prefix of j is nothing but sum of items from 0th index till j. Prefix of I minus 1 is nothing but sum of items from 0th index till index I minus 1. So we are gonna count how many times we have seen current prefix of minus k. That's all. That's the way we are gonna get the correct answer. So if you are even able to understand 50% of this till here, don't worry. Further we will be showing by doing more, then it will make much sense, है ना? एक बार check करके देखते हैं. Not just about this, एक बार check करके देखते हैं. Okay? So let's see. We are gonna create a hash map to store numbers. Okay? Index mapping. Now for each number in the array, because obviously we used hashing in twosome also, na? So what did we do? Why did we use hashing? To recognize if we have encountered B or not. है ना, किसी भी A पे काम कर रहे हैं तो हमने B encounter पहले किया है, नहीं किया है. If we have encountered, then we can clearly say that yes, we have a pair, है ना, whose sum is equal to target. So here also you can see the difference of prefix j and prefix I minus 1. We keep working with it, है ना, यहाँ पे. And prefix I minus 1 को हम लोग पता लगा लेंगे. How? With prefix, working with prefix j and k. If we have seen it somewhere, we will keep updating it. Okay, let's see here. So we are gonna create a hash map. है ना, let's say prefix sum frequency नाम है इसका. Prefix sum frequency means how many times that sum have occurred already. Okay, चलो वो देख लेते हैं. Key is sum and value is gonna be the frequency. ये कितनी बार में मिला हुआ है. Okay, so let's see. Then we will start traversing this whole array. 0th, 1st, 2nd, 3rd, 4th, 5th, 6th, 7. 7 items are there. 8 items are there total. And k is 7. Okay. Now, before moving to any of the state, before even starting, we need to be very careful about one case where the array given can be empty also. So if array given is empty, then by default take the sum 0 and put for sum 0 frequency 1. Okay, at least by default that's what we need to do to handle empty subarrays. Okay, now let's start from here. एक बार j को यहाँ से स्टार्ट करते हैं और i को यहाँ से स्टार्ट करते हैं. लेट्स से चलो j लिख लेते हैं इसको अभी के लिए और i पे रहते हैं. नो वरीज. ओके, लेट्स से people are saying i से स्टार्ट करते हैं. ठीक है, let's start with i only. So here and I have item 3. Okay, so what was the formula? What was the formula? Formula was prefix sum minus k. Prefix sum minus k कर देते हैं. Okay, so here the item is 3. Okay, and the sum would also be what? Current sum. यहाँ क्या आएगा? 3 आएगा. 3 minus 7 would be minus 4. Okay, so by this formula I am getting the value minus 4. I will look if minus 4 because this is the, you can say, for a sub array है ना, sum to be equal to k. ये माइनस फोर में वैल्यू एक सेकंड पार्ट की मिलनी चाहिए ना, जो शॉर्ट पार्ट था उसकी मिलनी चाहिए. So if it is already available means I have seen it somewhere, then it exists and I will increase the count. Otherwise, no. So I will check, is minus 4 available in my map? No. नहीं है, only 0 की entry. So what will I do? What will I do? I will put the entry of this sum. है ना, ये 3 की entry put कर दूंगा because this is my current sum for this current sub array which is of the length 1 only. So ये entry put कर दिया. I will move next. यहाँ आ गए. Now for this item as 4. So what will be the prefix i's sum की value क्या होगी? Prefix I is nothing but I is at 1. So sum of items at 0th and 1 index. Okay. So 3 plus 4. 3 plus 4 equals to 7, which I can see that I is 1, number is 4, sum is 3 plus 4 equals to 7. है ना, ये आ गया यहाँ पे. So I'm getting 7. Now 7 minus 7 क्या होगा? 0 हो जाएगा. So 7 minus 7 equals to 0. Okay, अब 0 हो गया means I have found it. है ना, means what? I found it because there was an entry of 0. हमने 0 के लिए एंट्री किया ही था. ठीक है, हमने 0 के लिए एंट्री किया ही था. ठीक है. So now what is gonna happen? I will update my count. Count initially हमें नहीं मिला था मैप में, so it was 0 0 only. Now my count value will get updated to 1 and I will make this entry of 7, okay, in my map. So 7 यहाँ पे 1 आ जाएगा and count have become, initially 0 था 1 हो गया है. I will move further. forward, यहाँ आ गया मैं. Then I am getting 7. So again, this step, index 2, I am at, and number is 7. So lastly, the sum value was 7. So 7 plus 7 equals to 14 हो गया. Okay, that's why 14 is there. Now 14 minus k, which is 7, I will get 7. Okay. So do I have this 7 in my map? Yes, I have this 7 in my map. So what will I do? Whatever frequency it is, it will be added in the count. So plus 1 equals to 2 हो गया अभी, ठीक है. And then what is the cumulative sum till index 2? 14. Prefix of 2 would be, prefix of 2 frequency would be added in the map. So 14 पे हम क्या करेंगे, 1 का काउंट लगा देंगे. Okay, frequency 1 put कर देंगे. That's what we are going to do. Next, I'll move to next item, which is at index 3 and item is 2. So index 3, item 2. Cumulative sum till here. So till last item my sum was 14. So 14 plus 2 is equals to 16 आ जाएगा. Okay, I am getting sum 16. Now I will subtract minus k, means subtract the k from this sum. So because the formula was prefix of I minus k. So 16 minus 7. What will I get? 9. Okay. Is 9 available in my map? Have I seen it earlier? No, I have not seen. So what will I do? What will I do? I will just put the entry of this sum. Okay. Put the entry of this sum in my map. Cumulative sum 16, 1, and count is not going to be changed, and I will just move on. So I am here right now. Okay. At index 4. So at index 4, what is happening? The item is minus 3. So cumulative sum till here will be 16, है ना, plus minus 3, which will give me 13. So 13 आ गया. Now 13 minus 7 would become 6. Do I have any entry of 6, Pelika? No, I don't have. है ना? That's why it crosses there. So that's why I will just update the entry of my cumulative sum here. 13, 1. Okay. That's all. Count will still be same. No issues. No change. Next, I move to the next item, which is at fifth index. Item is 1. So index 5, item 1. What is the cumulative sum till here? Previous cumulative sum was 13. So 13 plus 1 equals to 14. Okay. Now, prefix sum at I till I minus k. So 14 minus 7 equals to 7. Do I have a entry of 7? Yes, I do have entry of 7, है ना. 7 की एंट्री है तो मैं क्या करूंगा अभी, 7 की एंट्री है तो आई विल पुट इट्स काउंट हियर, है ना. सो ये 2 से प्लस 1 इक्वल्स टू 3 हो जाएगा. एंड देन व्हाट विल आई डू, आई विल अपडेट द क्यूमुलेटिव सम क्या है, 14 था, 14 आई ऑलरेडी हैव. तो मैं इसका एक एंट्री जो का अपडेट कर दूंगा फ्रॉम 1 to 2, बिकॉज नाउ आई हैव सीन 14 हाउ मेनी टाइम्स. Once I have seen 14 here, another I am seeing the 14 value cumulated sum here again. Okay. So next, let's move to the next step, or can say better to next iteration, which is at index 6 and item is 4. So index is 6, item is 4. What is the cumulative sum? Last cumulative sum was 14. So 14 plus current item 4 becomes 18. Okay, now next this formula, prefix sum till ith index minus target. So 18 minus 7, I will get 11. Do I have an entry of 11? No, I have never seen 11 earlier. Means it have not been found in the map. So I will just update this cumulative sum entry in my map, that at least I have seen 18 till here. Though I have not seen 11, but I am seeing 18 till here. Till where? From here till here, the cumulative sum have become 18. Okay. So ये one कर दिया. And count is still 3. No change in the count. Next item. I'll go to the next item, which is 2. Okay. So I'm here. Index is 7. Item is 2. Cumulative sum would become, last was 18 plus 2 is equals to 20. Okay. So 20. Next, here for the formula, prefix sum till index 7 is 20 minus 7 would become 13. Have I seen 13 earlier? Yes, in my map 13 is already there. है ना? तो true हो गया. So I will put its count here and add. So count is 1. So I will add 3 plus 1 equals to 4. ओके 4 ओनली एंड डू व्हाट एक 18 का एंट्री फिल कर दूंगा सो एक 20 का एंट्री फिल कर दूंगा सो 20 and the frequency is 1. After that, there is no more item in the array. So at the end, I have the value of count as 4. So there are 4 such subsets whose sum is equal to 7 till here. Okay, do you want to check how many, I mean, what are those subsets? So those subsets are nothing but these. One is items 3 and 4, index range is 0 to 1. So 3, 4 is 7, 0 and 1 index, 7a, which is k, you know. Next is only 7 is also there. Only 7 index 2. So 7 के equal है. Now next is 7, 2 minus 3. Okay. And 1. कितना आएगा? Index range 2 to 5. 3, 4. Okay. So 2 plus 1, 3 minus 3, 0. So again, this is 7 only. K के equal ही है. Okay. 3 items. 3 such subsets are there. 7 arrays are there. Then 1, 4 and 2. 1, 4 and 2. Sum कितना हो जाएगा? 7. Correct? And what are the indexes? 5, 6 and 7. So you might be thinking, say, this solution is not telling me about what are the indexes. Yes, it is not telling you about the index because the question asks, what is the question asked? Sub a sum equals k, and here they just want the count of such subarrays. They don't are not asking you to put the index also, though you can modify it later for the index as well, you know. But for now, you just need to tell how many times. Okay, so that's how we are getting 4. So I can understand that in the very first go, you might not get the whole, you can say 100% of the solution, but I will say try to solve it on your own again, at least one more time revision. But first focus upon the mathematical formula, how we derived it and what we're actually doing, and then compare it to the two sum problem. Two sum में जब hashing use किया था, then what we did. Then it will make much more sense to get to the clarity around what is actually happening, you know. So that's how it is gonna happen, and then you can drive in this thing and understand कि क्या exactly हो रहा है. Now let me show you the code कि क्या है exactly, how we are doing it. We are doing the same thing as we have told, the steps that we have discussed. First, we are gonna create the hash map, okay, to store number index mapping, okay, means cumulative sum. Not number, this is gonna be cumulative sum. Okay, cumulative sum index mapping. Okay, and not index here, frequency mapping. Okay, then for each number in the array, calculate complement equals to target minus current number, or you can say current sum minus target. This is also, I think this is on two sum. Okay, so current sum minus target. Okay, if it exists in the hash map, okay, you just need to, you don't need to return anything. Okay, need to increment the count, increment the count with frequency given है ना, frequency in hash map. Okay, अगर ऐसा नहीं होता है तो anyway store current sum, okay, and frequency. जो frequency आएगा फर्स्ट टाइम है तो 1 हो जाएगा, अगर नेक्स्ट टाइम तो +1 करना. ओके, इन hash map. That's what we are gonna do. So let's see here. Hash map created, named prefix sum frequency. Okay, now initialize with prefix sum 0 for empty subarray. We have done it. Put 0 1 in the prefix sum like we did here. 0 1 के entry put कर दिया था. Next, what are you gonna do? Put count equals to 0. Put prefix sum equals to 0. This is the running prefix sum for us. Next, I am going from I equals to 0 to the last item, and then I keep adding the items in the prefix sum to do what? Check how many times we have seen prefix sum minus k. That's what the formula was, okay? So prefix sum minus k is what we are going to check if it already exists or not, or if exists, then how many times? Because we stores the frequency of their occurrence. Like here you can see 14 को 2 बार देखा है, तो here it was 2 only. Now, if prefix sum frequency dot contains, अगर उसमें prefix sum minus k की value है, if it already have the prefix sum separated by k, then we will increment our count by the frequency that is kept in the map, not just a one, okay? Because the frequency can be more than one. So at the latest frequency, we are fetching it, okay? If it exists, we are fetching it and adding it to value of count, okay? We keep doing this. And once it is added, then what are we doing? We are putting the current prefix sum with its frequency. If it exists already, we are doing plus one. If it doesn't exist, then we are assuming it as 0, then doing 0 plus 1. Like you can see here, prefix sum is the key. Then we are trying to fetch the value of prefix sum from the map by doing prefix sum dot frequency dot get. But here we have written get or default. Here it was just get, here it is get or default. What does this mean? Means that if there is already some value there, means if this prefix sum already have an entry in the map, okay, then it will fetch the actual value there. What is the frequency there? That will be, if it is not present as an entry in the map, then by default, this 0 is what is taken as a value and then 1 is added there. Okay, that's how for any new item we are gonna put the frequency as 1. And any old item like 14, 1, it was old, so we added a plus 1 here, and we by default put 0 and then added 0 plus 1 as a 1 here, okay, for the new item. This way this whole process is gonna run, okay, and at the end, once this whole thing is over, you are just gonna return the value of count. That's all, nothing else. That's what we were returning, है ना, count 4 था, हमने वही किया था. So I hope this table would be very, very helpful for you in terms of driving. See, the more complex the problem becomes, the better it is to work on the driving much, much longer time. You know why? Because you need clarity around the visualization as well, how things are happening. And only Dragon gives you that to avoid major mistakes. Otherwise, you will think that ki हाँ आ गया समझ लिया problem. You understood. You think that now you got the whole idea, but once you try to implement it on your own, you will get stuck. You'll think you'll try to rely upon your memories, but memories doesn't help you. Memories can give you a hint, but they doesn't give you the whole implementation. Why? Because there are gonna be hundreds of thousands of problems to remember. कैसे करोगे? Right? So that's why please design it on your own again using this tabular method. This is doing nothing but write this algorithm one side, put this empty table one the side, okay, then try to fill this using some array values, okay, then that will help you much better. So we saw how many subarrays are there which are contributing to the sum equals to 7, okay, that's how things happen here. Now let's move to the time and space complexity of this solution. So the time complexity of this solution is we are having a single pass only, as you can see, one for loop, and rest of the things are just computed by the formula, nothing else. So order of n for the time complexity, hash map operations, fetching and putting takes order 1. So average case order 1 is, so no issues upon here. Each element processed once only. So the whole time complexity would be big of n only, nothing else. Space complexity, because we are using hash map, and if all items are unique, and all sums are unique, that's what it is written here, I think also. Worst case, order n when all prefix sums are distinct or unique, है ना? Then big of n only for the space also. So let's have a clear comparison between brute force and the prefix sum plus hash map solution. Brute force, we were generating all the sub-arrays, so that's why it is order of n square. Space, though it was order 1, but it was slow. Because this is the point where we need to talk about the trade-off between the space and time complexity. Though here it was taking longer time, but the space was constant. But does it really matter? So the answer is, if the input is smaller, it works and it's a good situation. We don't need to optimize because anyway we are at a good place with the space also. But the input is larger. Slow for large input, है ना? Large input हो जाएगा. Greater than 10,000 size का. Okay, so it will become slow. So you want to get things faster also. So that's where the trade-off comes into play. You can use this approach for larger inputs. Time would be constant. I mean, linear हो जाएगा, not constant. Here it was polynomial, so it will become much faster. It's just that it will require an extra memory of order n. Okay. So all you can say for n equals to 1000, brute force take 500,000 operations, while your solution takes 1000 operations. So anyway, that is 500 times faster. Though this n equals to 1000 is very small, don't take it practically. Should be putting a larger number there in terms of billion, I would say. Nothing less than that. Then you will see the magic that how fast it becomes once a solution takes order n time instead of polynomial time. Okay. So I hope this is clear to you. So from here we will be moving to the next problem. Next problem is relatively easy, but it will give you the whole idea, or you can say this problem is majorly on the practice side for you, and this gives you idea around how and where you can apply it wherever you feel applicable, you know, because this tells you more about what are the edge cases that you must be aware of, not just blindly applying things. Because instead, I mean, and at that time also, if you think that you are correct, yes, you will be correct, but at the same time, still all the test cases won't be working for you. So let's see what can happen. So in this particular problem statement, check if two arrays are permutations. So let's understand this first. Given two integer arrays, determine if one is a permutation of the other. Okay, दो array आपको दे रखे हैं, and you need to determine if one is a permutation of other. So array permutation means what? All the items of the arrays should be same, and not just same. The number of times they are existing should also be same. That's why it is written same frequency of each element. Okay, nothing less, nothing more. Different order is allowed. You know, let's see this through the example. Let's say our first array is 1, 2, 3, 4, and 5. Next array is 5, 4, 3, 2, 1. So here you can say all the items are same 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay. Frequency means the occurrences of the items. 5 one time hai, 4 is also one time here, 3 is also one time, 2 is also one time, and 1 is also one time. Frequency is same. Different order allowed. Yes, 5 is at what position? 0, 1, 2, 3, and 4. Fourth position, and here 5 is at the 0th position. Correct? Same for rest of the items as well. It should not be for all items also. Even if one item is there, that is okay, no issues. Don't say कि सारे items नहीं थे, कुछ same पे भी थे, है ना? Like 3 is at the same place. Still, it is a permutation. Okay, don't worry. So then, only in this case, the output is true when all these three conditions are satisfied. All the same elements are there. Their frequency is also same, and different order is allowed. No issues upon that. Example 2. So in example 2, we have what are items 1, double 2, and 3. And other array have 1, 2, 3, and 4. So here you can see 1 one time आ रहा है, ठीक है. 2 is coming twice है ना, but here 2 is once only. 3 is coming once, 4 was not available here. So that's why false हो गया. Not a permutation. This was true. This was a permutation. Okay. For this also 1, 2, and 3, and 1 and 2 only. This is matching. This is also matching, but it's still false है. क्यों? Because first I have one more item 3, and 3 is not available. That's why it is false. You can see clearly the answers. Okay. Next is all items are same. 5, 5, and 5. Next array also have 5, 5, and 5. So it would be true. You know, the answer is true here. I hope this question is clear to you, the following statement. And most probably, I'm expecting that most of you must be able to solve this on your own as well, because of the things that we have learned till now. It would be relatively easy, right? That's what I'm expecting, but it doesn't happen, right? Mostly it doesn't happen. So let's move to the approach part. So brute force. In the brute force, what we can think of? Obviously, for each element in array 1, we will find a matching unused element in array 2. Because why I'm saying unused? Because there can be multiple occurrences. Yes or no? कोई आइटम मल्टीपल टाइम्स आ सकता है, मल्टीपल occurrences of same item. Let's say 1, 2, 2 and 3 is in the array 1 and array 2 have 1, 2 and 3. So by the brute force you will see for each element in array 1 find matching element, correct? So if I go for here and start my j from here, so what will I be doing? For 1 I will start from here and go through all the items. So 1 I found at the very first place. Chalega. Good, very good. So match found, no issues. Then I moved my I here. 2. I again started my j from the beginning. 1 is equal to 2, no, nahi hai. 2, then I will come here. Is 2 equals to 2? Yes, it is. So what will I do? I will move forward and put next item. And my j will be again starting from the beginning, है ना? For every item I will start from the beginning. है ना, क्योंकि पहले भी कुछ हो सकता था, हो सकता है कि पहले जंबल ड्रॉ ऑप्शन 3 यहाँ पे भी आ सकता था, है ना. So there is no order, so I will start on the beginning. Then 1 equals to no, I will move forward. 2 is equals to yes, good, so I will move forward here and here. 3 again I will start my search from 1, है ना, 0th index. 1 equals to 3, no, I will move my pointer or j index here. So 2, item is 2 and item is 3 here. Not equivalent. So I will move my j here to the third item or index 2. 3 is 3. Yes, this is a match. So I will say array 1 and array 2 are permutations with this logic. But is this really correct? No. Why? Because this 2 was already used by this 2, है ना, इससे use हो गया था. So this 2 can't use this. That's why I have written here. Find matching unused element in array 2. So you need to be very, very cautious about. That's why I said people think that it is easy, but it is not that easy. You need to be very careful about too many edge cases. One of the edge cases like this only. When one array have repeated item, other doesn't have, though the distinct items are same. You know. So this is one case you need to be focusing, or you can say worried about. So to take care of this in brute force, what we can use a, you can say array to keep track of the used item. Use an, or you can say a boolean array to keep track of used items. Unused, to keep track of unused items by marking used items. Used को mark कर दो so that you will get all the unused items. Okay, that's what is gonna happen. So don't worry. So as you can see, step one में array one में item index 0 have item 1, but here we will search to the whole array. We will get 1 here at the index of 1 and I found it index 1. So mark used 1 है ना, mark used 1. अब used हमें किस पे mark करना है? Think about it. Mark used 1 किस पे करना है हमें? Obviously, we are looking for items from array 1 in array 2. So this Boolean array would be for array 2. Okay. So it will be looking like used. Array 2 में क्या है? 4 items. 0, 1, 2 and 3 index. So initially सब पे तो by default false होता है. Okay. So if I'm using this one from array 2 to compare with this one from array 1, what will I do is I will simply just mark the index as true, means use हो गया है. Okay. Next, what will I do? Next, I will come to the second item, which is 2. So for this 2, again I will start my journey from the beginning. सो टू इज देयर है ना, यहाँ से टू के लिए स्टार्ट किया था, फर्स्ट टू हमें मिल जाएगा एंड इट वाज फॉल्स सो इट वाज अनयूज्ड है ना, सो इसको यूज कर लिया फॉर दिस टू टू मैच एंड मार्क दिस एज ट्रू. Next, I will come here. Again, this is 2. So for this 2, what will I do? I will go to this array again. I will start from here. I will see कि 2 यहाँ पे है. But I won't be using it. Why? First, I need to check if it is used already or not. I will see. 0th index, it is true, means used already. So I will go where? I will move forward. Go to 1 index. Item is 1. So if item is 1, so anyway, I'm not gonna compare it for using Henna because I am looking for 2 right now. This 2. So what will I do? I will move forward. 3 is there. No, not a match. Move forward. 2 is there. This 2 is a match, but I will check. At index 3, is it is used? No, it was not. It is false. So I will mark it used for this 2 now. Okay. And I will move forward to last item 3. For 3, I will again start my journey from the beginning. 2 not a match, 1 not a match, 3 is a match. But 3 is 0, 1 to 2 index. I will see. Was it used? False. No user. So I will mark it true as it have been used for this 3. Next, there are no items. Once there are no items, है ना? And because I have completed all the items and कहीं पे मुझे ऐसा नहीं मिला कि वो true already था, so I will say yes, return क्या होगा finally true, it is a permutation, है ना? Answer जो होगा final. That's why it is written here. Final output is true only. Okay. So let's have a quick check on the code. Okay. Two arrays are given. What I am doing? First I am doing what? Checking the length because number of items equal होनी चाहिए मतलब length भी same होनी चाहिए ना. Quick length check है. These are the edge cases that you need to be very careful about. These are not actually discussed in the dry run, but you need to be very thoughtful while solving these kind of questions, है ना? Because this is common sense that if I am saying number of items should be same, correct? फ्रीक्वेंसी ऑफ ईच एलिमेंट आना चाहिए यहाँ पे. अब सबका होना चाहिए एंड सेम एलिमेंट से होना चाहिए. तो एटलीस्ट दिस टेल्स यू लेंथ ऑफ बोथ arrays should be same. Okay, so that's what is gonna happen here. So we are checking length. If it is not equal, return false directly. Otherwise, now track which element in array 2 have been used. To track it, we are gonna create a boolean array named use of length of array 2. Okay. Now for each element in array 1, find the match in array 2. How? So access element in array 1 first. I equals to 0, length of array 1 till length of array 1 and I plus plus. We are checking our one more because this boolean variable is telling us for the instant result है ना, क्योंकि अगर एक भी मैच मिसमैच हुआ ना, even one mismatch or match not found, not mismatch actually, match not found would lead to false as output. Okay, that's, I mean, this means that we don't need to calculate any further. That's what I'm keeping a boolean variable as false initially. If I get a match, I will turn it to true. Otherwise, if it is false, and for this for this inside for loop, then once I come outside, if it is still false, I will return false. That's all. Means I would stop computing further. So search for matching element in array 2. Now, while picking an item from array 1, I am gonna check that item in array 2 by keeping track of this found. Okay. If first I'm checking in the used, if it is used or not. So in the used, what was it? In the used, everything was false. पहले से ही, yes or no? पहले से ही false था, है ना? So for this it was false. So not of false will become true, है ना? And array I is array 1 I equals to array 2 j means we are matching the item. If it is also true, then only mark the used as false. Otherwise no, है ना? Used of j is equals to true. हाँ, false था ही, true mark करेंगे. Sorry. Used will become true. Okay, mark as used. And because we are able to find a match, for this particular item we will write found equals to true है ना अभी के लिए, and then found path ही break because we are not gonna check it further. Now we will move to the next item. So before moving to next item, what is gonna happen if loop यहाँ sorry, if a statement is closing here, for loop for the j मतलब part is closing here, here is gonna happen what? We are again checking for my found variable. I told you it checks if it is matched or not. If it is not matched, even one failure leads to the complete failure. That's why it is checking. So if found was true, and so not a found will become false. So this is not gonna run, and my for loop will get reiterated. That's how it is working. Okay. So I hope this is clear. You can run it again on your own also because I have done it already here. Anna. So this is just the code that is gonna do the same thing. And at the end, once things are done, I am just returning true directly. Okay. So now, why this is efficient or inefficient? Efficient तो लग नहीं रहा कहीं से. Why? Because big of n square ना time. Big of n square. So I have not told you yet, but I am expecting that since we have come this far, so you must be able to figure out the time here. Every item is compared with every item of the array 2. है ना? N items here, n items here. So big of n square because two nested loops are being used here. And extra space order of 1 if for the boolean array है ना, space complexity is big of n. Repeated search is linear search for each element. हर element के लिए हम लोग repetition search कर रहे हैं. Repeated search is happening here. Okay, so time complexity n square, space complexity order of n. That's why it is inefficient. Okay, now let's try to move forward and think कि हम क्या कर सकते हैं. What else we can do to move forward towards the optimal solution. So here, what's wrong with brute force? रिपीटेड लीनियर सर्च हो रही है फॉर ईच एलिमेंट वी स्कैन एरे टू लीनियरली है ना, एक आइटम के लिए वन आइटम टेक्स बिग ऑफ एन टाइम्स, एन आइटम्स टेक बिग ऑफ एन मल्टीप्लाइड बाय एन टाइम. Okay, that's why n square is there. Now, no frequency tracking. We don't remember that array one has two twos है ना, उसके पास दो दो है वो हम लोग रिमेम्बर नहीं कर रहे हैं. So that's why we need to keep track of using the used array or the boolean array. Extra space इसलिए use हो रहा है. Okay, there. Now inefficient matching. Manual element by element matching instead of frequency comparison. एक बार में, I mean, we have learned what all the logic that we have learned till here. We can easily think that somehow I can get some logic which can help me to keep the frequency of all the items in the array one. Correct? We are not doing it yet. That's why in the optimal approach, we are going to use the hash map to count frequencies of items in array 1. Okay. And for array 2, we'll keep decrementing the counts. If all the counts are 0, means there are permutations because it is more like Ram have 2000 rupees. Correct. Sham wants 2000 rupees from Ram. So if Ram agrees to give it to Sham, then finally Ram would have zero money. That tells that the transaction was successful between Ram and Sham. Otherwise, otherwise it was not. It would be not. है ना? अगर जीरो नहीं होता है मतलब राम के पास कुछ ज्यादा ही पैसे थे, एग्जैक्ट 2000 नहीं थे. श्याम ने 2000 समझता हुआ मांगा था. श्याम asked to Ram for 2000 because he knew that Ram have 2000 only. है ना? So this whole scenario is gonna work like this. Means two arrays are permutations if they have identical frequency distribution. So this is like inventory management. Count everything first and verify the total match. Totals match है ना? कैसे होता है? Let me show you. So this example. 1, 2. Let me just copy this. I don't know why it is not getting copied. Just a minute. Okay. Let's see. So here if I put, okay, it's not copied, but yeah, I think I have it already. So no issues. Yeah, here. Let's say array 1 have items 1, 2, 2 and 3, correct? ये भी है. Array 2 have items 2, 1, 3 and 2. Okay. So if I count the frequency of all items while traversing array 1, so क्या हो जाएगा? For item, comma frequency. Okay. 1 is coming one time. If I'm here, then I will go to next item 2. 2, I am just putting its value as 1 because I have seen 2 till here only. I will go to next item. Next item is 2 again. So I will increment the frequency to 2. Next item 3. It was not available, so 3 is one time. Okay. Now I will start traversing my array 2 from here. And I will check if this item is in my is in my frequency table. Yes, because 2 have an entry here. Okay. So I will just decrement the frequency. Frequency will decrement it to 1 क्योंकि एक ही 2 था, एक 2 से cancel कर दिया. I'll move to next item 1. 1 is available? Yes, it is. I will decrement its frequency by 1. So 1 minus 1, it will become 0. Next item 3. 3 available? Yes, 3 is available here. If 3 is not available, then also I can directly return false. कि तो match ही नहीं किया ना, 3 था ही नहीं यहाँ. And item से match करने चाहिए. Decrement its frequency by 1. 1 minus 1, 0 हो जाएगा. I will go to next item. 2 is there. And for 2, I will check. Is 2 still available? Yes, 2 have an entry. What is the frequency? If I do minus 1, it will become 0. है ना? तो 0 हो गया. Let's say एक और 2 आता. फिर I will check. And frequency is 0. Then also I will just send false. है ना? 0 भी नहीं होनी चाहिए frequency. So till here, now once the whole traversal is over, I will check is my map. Either I can, once the frequency is 0, I can delete the entry, or I can go through the map again and check all the entries as 0 or not. Both ways it can work. And if either all the whole frequency table is empty or all the frequencies are 0, then I can really say that yes, these two arrays are permutation. है ना? ऐसे कह सकते हैं. So now let's see क्या कर रहे हैं हम लोग. If arrays have different lengths, they can't be permutations. Check. We have established that. Frequency counting. Use HashMap to count element frequency in array 1. That's what we have tried to do here. है ना? Item and frequency. Next, frequency verification. For each element in array to decrement its count in HashMap. Yes, that's what we did. That's how we have achieved the count as 0 or the frequency as 0 for all the items. Now validation. If any count goes negative or HashMap not empty, then it is not a permutation. You can return false directly. Return false. Okay. Simple है ना? कब simple लग रहा होगा? Great. Now you are getting the idea. But there's no such thing like rocket science in data structures and algorithms. Everything is complete common sense, है ना? It's just that you need to figure out ways how to apply what and where by practicing a lot, okay? Now, why this works? Handles different orders naturally because once we start counting the frequency and HashMap allows us to access items in order one time, now order doesn't matter, okay? Because we have written the frequency कितनी बार आया है and we are decrementing it as well. Early termination on mismatches, exactly. Let's say if I had 4 instead of 1, you know, and there was no entry of 4 here, I could have directly returned false as the answer. Okay, not doing much there. So now here, order 1 frequency checks. That's what is happening. So we are building a frequency profile and verifying the second array matches it exactly. Okay, let's see here. Frequency build frequency map for array 1. Array 1 को पहले access करते हैं and let's try to build a frequency map. So I will go to item first, which is 1. So I will put an entry in my map है ना hash map for frequency. ठीक है 1 पे 1 के लिए if I look at 1, I will put the entry as 1 and value as 1. What key value pair होता है ना key and value. key क्या है item, value क्या है frequency. Okay, so 1 is coming one time. Now if I go to next item 2, I will put an entry for 2 and value would be 1 because the frequency is 1 right now. I will go to next item 2 again. So again, if I reach 2 again, I will just increment the frequency as 2 है ना. So 1 की 1 थी, 2 की 1 थी, अब 2 हो गई है. Next I will go to next item again 3. So I will put an entry of 3 and frequency 1. Okay, that's what I'm gonna do. Now step 2, verify against array 2. Array 2, I will start counting from here. So I will access the item. First item 2 is there. So 2 अगर यहाँ पे तो क्या होगा फिर? I will look for it in the map. Okay, and I will do what? Decrement the count. 1 पे ला दिया. ठीक. 1 काउंट क्या हो जाएगा? 0 जाएगा. यहाँ पे काउंट क्या था? 2 था, 2 से 1 हमने कर दिया by reducing it. So new entry is like 1 1 2 1 3 1 1 1 2 1 3 1. Okay. Now for 1 is there, count was 1. So 1 will be reduced to 0 because I am reducing the count because I have encountered 1 one time. You know? So now that once the value have become 0, what I am gonna do? I will remove the entry of 1. So I will remove it from my a map. Okay. Now I have two entries only because once the value becomes here, remove it so that at the end we can check if the map is empty or not instead of checking the values are 0 or not. Okay. For 3, if I come to item 3, I will check is the entry yes. Frequency is 1. So 1 minus 1, it will become 0. Once it have become 0, I will remove the entry. Remove 3 from this map. So only 2 and 1 is there. I mean 2 with value 1 is there. I will go to next item which is nothing but 2. So here count of 2 will be 2 will become 1 minus 1 0 है ना, ये भी 0 हो गया. And once it has become 0, remove 2. ये भी हमने फिर remove कर दिया. Next, final check. Hash map entry. It's empty. If the hash map is empty, then return true. Otherwise, return false. Okay. So that's what is gonna happen. Let's have a quick look at the code also. Why don't do the code very early stage? Because that's not the effective solution or effective way of learning DSA. First, build a thought process using the things that you know already. Okay. जब इतना समझ जाओ, create the flow, try run it. If you are reaching the answer, then try to code it further. Don't write the code initially. This doesn't help. I know too many people have this habit of doing this. They might be successful as well, but this is not the ideal way, not the very best way. That's what I can tell you from experience. That's why people use pen, paper, and always write things down, what is happening in their mind regarding the solution. Then there comes the last thing as the code. Okay. So let's have a quick look. What I'm doing, two arrays are there. And then first you're checking the length. If they're not same, then return false because if the length is not same, then the items are not going to match anyway. Hash map we are creating. Okay. Key is the number. Value is its frequency. Okay. That's what we're creating, named as frequency map, FEC map. Okay. FREQMAP. Okay. So next is we are gonna count the frequency of items in array 1. All items. There is another way of writing the for loop using an iterator named num. So frequency map dot put num comma frequency map dot get default means if the entry is not there, so by default it will become 0 then +1. If the entry is there, so whatever entry is there, bring it out and then do the +1 and then put it there. Okay, so that's how we are putting. So 1 का 1 रख दिया था, 2 का 1 फिर 2 रखा था, 3 का 1 रखा था. Okay, now verify frequencies against array 2. So here again for loop, num is the same again reinitialized, so it will be working for array 2 now. If num is not in map, keep permutation, not permutation. So first, any item which we have seen in the array 2, we will check if it is there an entry of it in my frequency map or not. Like what is the items 2132 array 2 में array 2 2 1 3 and 2 है ना. For 2, I will first check if 2 is available or not. So frequency map dot contains key num contains key 2. Yes, it is true. True है, then not of true will become false है ना. तो क्या होगा, ये नहीं चलेगा. I am not returning false here because I am putting that not operator. Next, count is equals to पहले how many times it is there, already the entry is there, so I am getting it as a 1 है ना यहाँ पे, the value of the key. Okay, now if count becomes 0 तो रिमूव करना है. So if count is equals to 1, अकाउंट 1 है ना, तो रिमूव कर दो because अभी तो मैच हो गया है, we have matched it now, so anyway it is going to become 0, so remove the entry. Otherwise just reduce it by 1 है ना, frequency map dot put number comma count to -1. This is my key and this is my value. I hope you know how this works. Okay, the hash map thing. There's a value we are putting. And how we are putting it? By reducing the count by 1 if it was not 1 already. Because if it was 1, then reducing it will become 0. So instead of putting it again as 0, we are directly removing. I know. We are directly removing the item from the map. Okay. And that's how things are happening here. Then again, one more for loop. So this way you can see that once things are over, I'm again checking if the entries in my map are over or not. If all the entries are deleted, ये one, then चीज़ okay, delete हुआ था, ये चीज़ okay, delete हो गया था. Now map is empty. Now map is empty. Okay. And once my map is empty, okay, I'm outside of the loop, I'm checking. Frequency map dot is empty. If it is true, return true. If false, it can return false as well. Okay, so that's how the solution is. Now let's check the time complexity. वो कैसे होगा? This for loop is taking how much time? Big O of n है ना, इतना ले रहा है. And this for loop is taking how much time? Big O of n. Because both arrays are of same size. है ना, नहीं होता तो यहीं से false हो चुका होता पहले ही. This line. Okay. Big O of n plus big O of n कितना आएगा? Big O of n only, the time complexity. Okay, space complexity, because anyway we are using hash map, so worst case में big O of n for n distinct items. Okay, इतने होंगे तो big O of n ही हो जाएगा. So that's what it was all about. Now let's have a quick look at the complexity analysis. है ना, same thing I have shown you. Brute force order n square and space was order n, but hash map order n and order n. So all case you can use it. Okay, I hope things are clear. Now when to use hashing pattern? So by some problems we have seen it already. So variations, the variation of those problems, so subarray sum equals k, continuous subarray sum, binary subarrays with sum, okay, and then key क्या होता है? Prefix sum plus hash map. That's what we have used today. Okay. So these are the factors that you can, think of while you are even heading towards thinking कि hash map use करना नहीं करना, hashing pattern use करना नहीं करना है, okay. Wherever frequency counting is needed, that's it also you can use, okay. There's some questions there, contains duplicate, first unique character, array permutation, these are the things where you need to calculate the frequency, means the occurrences, okay. Existence checking problem, obviously, hash map is built for that. If something exists, then hash map would have the entry, if doesn't, it doesn't have the entry. That's what we have used in the first problem from today as well. Okay. Now, common edge cases and solutions. So empty array भी हो सकता है. So if the both arrays are empty, then output will be true. If one is empty, one have something, then output would be false, not zero. Okay. So length checking gives you an edge over this. That's what we were doing in our solution as well. We were checking the length first. Single element. एक ही आइटम में ट्रू कर दिया. You need to think about this case as well. वैसे तो ये the algorithm that we have used, it naturally takes care of this particular situation, but you should not be careless about this. Okay. So all same elements, सारे items same हो जाए तो भी okay. Next, frequency counting से you can handle this. Large values, then you can use integer dot max value और small value तो integer dot min value भी आप use कर सकते हो. Okay. That's what you can do. Then no solution. For what? Let's say input is 111 k equals to 5. तो आउटपुट नहीं आने का था, है ना? किसी भी सब array का sum, there is no such subarray which have sum equals to 5. So no output भी है. So these are some cases that you need to, think of. And in for the second problem, 1, 2, 3, and 4, 5, 6 means all the items are completely different. So when you are trying to figure out some solution for a problem, first you need to, while thinking of the approach, you need to think about some cases also, boundary conditions, which are called as the edge cases also. You need to think about it, then your only your solution would be better. Okay. So this was a glimpse of what are the cases you can think of. There are more, but I will leave it up to you. Now, real interview questions and variations around the things that we have learned. Okay. So Google variation was in Google what the question was asked was sum equals k जो हमने solve किया था आज. Group anagrams frequency counting type of question it is. Longest substring with k distinct characters. Longest substring with the sum k, we have already done that, you know. I think you'll be able to apply this also. I mean, solve this also because by applying that solution, a little variation is there, but you need to figure it out by solving this. This will really help you, okay? Now, Amazon variations, two sum variation. Two sum के बहुत सारे variations होते हैं. Some of them I have discussed already, and I've given you in homework also. Please solve it from the earlier sessions. Like most frequent or elements, shopping options combinations are there. Those kind of things. Combination में क्या आता है? Means you have limited amount of money. Then what are the items that you can particularly pick in that limited amount of money, and yet you will be happy. Some kind of question is there. Okay. Microsoft variation. So continuous subarray sum is the question, and palindrome permutation is there. Array partition problem is there. Okay, so these are the kind of questions that you may encounter. Meta for the Facebook, so subarray sum divised by k. We have already seen to the average, so divised by k also I can think that we can solve it. Then contiguous array equals zeros and ones. Okay, so it is more like ये two pointer का एक बहुत ही classic problem है. Classic two pointer problem. Okay, I will really ask you to solve this kind of question and बहुत easy होता है but gives you better clarity to pointer problem. Find out the anagrams in a string also. I think today's last question would be very helpful for you in terms of giving you some ideas on how to solve this. Try on your own, okay? Because anagrams definition will give you better clarity, which will further relate that question to this current question that we have solved today. Okay. Now homework and practice problem. So I will really ask you to implement for the foundation level, implement both problems with detailed comments. Comments give you clarity, you know. If you just memorize the code and then keep pasting it from your memory, it doesn't work that way. If you can define each and every line, put proper comments in your code, means you have got better clarity, otherwise, no. So that's why you make it a habit of putting comments in your code properly while you're coding. Test with all provided exam. This and these gives you like placeholders to fill, है ना? ऐसे आप भटकते नहीं हो. You don't get diverted from your goal while coding. So just to make a framework of logic through the comments first. Okay. So try and do all the things. Complexity analysis is there. Then sub you can try these problems to build a confidence. And for the interviews, some variations you can go for these questions on lead code. Longer substring without repeating characters, top ke frequent elements. Okay, and then contiguous subarray. Contiguous array binary transformation. Okay. I will try to solve this question in next because this seems very important. I will try to solve this question in the next session as well. Okay. Now, key takeaways. So, conceptual understanding. We learned how to optimize our solution from order n square to order n. We solved prefix sum plus subterms using prefix sum plus hash map. Okay, and then we solve next problem of permutation by having the frequency counting. Say space-time trade-offs was also what we saw earlier. Okay, rest is I think same that we have learned, so no issues. Now, just to revise and give you better clarity, you should ask a few questions which are written on the screen right now to yourself once you have learned things. This will give you better clarity. I mean, these are more like key understanding pointers, you know, around the question why we did what we did, you know. So that's why you need to be answering this. Why do we initialize prefix sum frequency with 01 in subarray? Remember, that's what we did in the very beginning. Though I told you the answer, but I really want you to answer it on your own as well once you are over with this lecture. What's the advantage of frequency array over hash map for limited character sets? I know. Limited character sets is the key, so please answer accordingly on your own in your textbook. How is survey sum problem similar to two sum? That also I showed you when I was explaining. So I'd really like you to answer it on your own without revisiting according to what you understood from the session, because that will give you clarity around where you really stand in terms of correlating with the problems. Okay. Otherwise, you can revisit as well and try to get the answer. When would hash set be sufficient instead of hash map? Find it out, okay? And if needed, you can go through the documentation as well. Challenge problems. Can you solve subarray sums divisible by k? You can try it. Find all anagrams in a string also. Though I'm not taught a string, but I think some of you might know, so you can attempt this question, okay? Now, tomorrow at Aarush Coaching Classes, we'll try to solve these questions. We'll complete definitely solve, not just try to. Product of array accept self बहुत ही classic question है. Always asked in most of the interviews. Then rotate image. Matrix rotation is there because the image is generated in the form of matrix. Okay, this will we will also see. It looks a little easy, but when people mostly try to solve it, they get stuck with some calculations. So that's why I think that this should be cleared in the live session as well. Okay, because some people are writing, so this problem is what they get stuck the most, and they need some clarity. So I will show you this one also. Okay. Why these matters? Again, for the interviews, build a foundation, real world application में क्या होता है काम, pattern recognition thing is there. Okay. So I think I don't need to repeat. But yeah, the point here is overall is you are running on the right track. Okay, we have covered a lot of patterns and which can help you further solve multiple questions which are being asked already in the interviews. Okay, so I will really appreciate that if you can solve more problems around it, because showing you solving all the problems is not feasible enough, but showing you the pattern, because see, problems you can't learn, but there are some premium classic problems which covers most of the category, you can say categorical patterns, 100 to 100 problems. If you can solve those, rest of things would be a piece of cake for you. Okay, so please focus around it only, keep your focus around it only. And if you are finding these sessions meaningful, if doubts are getting cleared, if your understanding has become better in terms of observing the patterns and understanding the patterns as well, please do like, share, and subscribe this channel. And we'll keep posting upcoming sessions right on the schedule, and keep watching. Thank you. That's all.